Hello. The EuCAPT
Hi.
video profile series consists of interviews with members of the community active in theoretical astroparticle physics and cosmology. In these interviews, we discuss what's exciting in research, life in academia, and developments within the research community. I'm David Marsh. I'm an assistant professor at Stockholm University, and today I'm excited to be joined by Alexey Boyarsky, who's a full professor at University of Leiden in the Netherlands and has made a number of important contributions to astroparticle physics, cosmology, and particle physics. Welcome, Alexey.
Yeah, nice to see you there.
So let's start by getting to know you a little bit. So first off, where are you from and how did you become interested in physics and science?
Yeah, I'm from Ukraine. I was born in Kiev and spent first 16 years of my life there. And well, I read books, and in the books there were people doing magic, and I always wanted to be a magician. And then I realized that there is only one kind of magic that works, which is you take a phenomenon, you can observe it if you want to know more about it. But there are objects that you invent, like triangle or differential equation, and those you can reason if you want to know more about them. There is no magic in both. Both are very cool, but no magic. Magic happens when someone guesses that this object is very similar to that mathematical object. And then you put a link between them, and then you can take the results of your reasoning and project them onto real world, and then you can predict the results of measurements or observations, or find new ways to observe something, right? And then this simple idea, it's really a magic that works and creates all these beautiful miracles that we are surrounded by in modern world. And I realized it at the age of about, I don't know, 15, 14, and then I wanted to do that. And that's science, and in particular physics.
Cool, very cool. So can you briefly describe what your career trajectory have looked like? What positions you held, and when and where?
Yeah, I started, I'm not so young anymore. So I started when Soviet Union was existing, and there was this Institute of Physics and Technology founded by Landau and Pizza long ago. It was quite popular because it was just gathering past people working in physics, in all kinds of physics from this huge country, former Soviet Union. And there were about 10 faculties, and all faculties of physics, different kinds of physics, cosmic physics, chemical physics, general physics, physics of energy, physics of space. And each faculty at each year contained like hundreds of students. So it was a huge educational institution, all devoted to different aspects of physics and application to technology. So I went there when I was 16, and I became 17 when the first year started in several months. And then I got there my bachelor, master, and even PhD. And then I went for a postdoc to Utrecht. And I had a great opportunity to do it with under supervision of Gerard Hooft, who just got Nobel Prize a couple of months after I arrived. That was quite funny. And then I was in Niels Bohr Institute, and then I spent many years in Switzerland, working in Lausanne, in École Polytechnique Fédérale, and then in CERN, being CERN fellow, and then in Zurich, in ETH Zurich. And then I moved back to the Netherlands as an assistant professor in Leiden, and then I'm still there as a full professor. Yeah, that's my career path, basically.
Cool. So in your research career so far, so at what point were you the most excited, and what was the research topic that you were excited about?
I was always super excited about physics, about anything I did. I could say that I started with more not abstract. I was never interested in abstract. I've always wanted to describe the real world, but I didn't understand how to do it first. So I studied more, let's say, things like anomalies, extra dimensions, even a bit of string theory, although I was never a big fan of it. And black holes, of course. My PhD thesis was a quantum mechanical model of a black hole, which I was very excited about. But then all this was very nice, and I thought I'm trying to describe the nature in this way. But then I realized that you really need to work closer to the data if you want to describe nature. And this is what I strongly believe. And I started to do more particle physics, and then I started to use data from astronomy and observational cosmology. And then I learned how interesting all this is by itself. Like, if you want to use LHC, let's say, right, apart from having a model that you want to test, a model of particle physics, you need also a model of this experiment, because it's enormously complicated. It's a part of your model, actually, if you really want to use it to learn something new. And this is extremely interesting. And the same is true in astroparticle physics. If you want to use early universe or stars or galaxies or clusters or intergalactic medium to extract physics information, you need first a model of what your system is, apart from new physics, apart from particle physics theories. And it's very, very cool, because you can study it, you can understand it, you can predict, you can check. And so that's how my thinking developed.
So in your research area at the moment, so what are the questions that you think are the most exciting?
Well, I think, like many of us, I admire the standard model. I teach a course where I start in 1934 or 36 with Fermi, with the theory of beta decay. Then I show students how it evolves to 1967, to the famous paper, The Theory of Leptons by Weinberg. And then I tell that the rest, the rest of 20th century and a bit more, we spent testing all that. And this worked, despite Weinberg saying that our theory has so many arbitrary features that its predictions should not be taken seriously. We learned that it should be taken seriously, extremely seriously, and because they are all correct. And still, right, we cannot explain what dark matter is, and I'm totally convinced that it exists. We cannot explain how this hot universe full of particles and antiparticles cool down, and some particles didn't meet their antiparticles, and matter-antimatter symmetry was somehow generated. And this is a big mystery, because standard model, it couldn't happen. And also neutrino masses. These are three things that we know they exist, and we know that they're not described, they should not exist in the standard model. And it sounds very simple. We have to find out how to extend the standard model. But the difficult part starts when you have to decide how do you extend it, because there are so many possibilities, and it's not easy to invent a new one, or tens, or the extension number 10,533. But the problem is how to educate ourselves which ones are going in right direction, right? So this I think it's the main question for particle physics or fundamental physics, whatever you call it. And then you can answer it in two ways, either doing experiments in the lab or at accelerators, and I'm doing that. I'm an advocate of new approach to accelerator experiments. I think we have underexplored intensity frontier type experiments, which can give us a lot of chances to go into unexplored area and probably to find something there. In addition, right, not as a competitor, but as a complementary to energy frontier collider type experiments. And I'm part of one of such collaborations. And yeah, it's very important for me. On the other hand, you can learn from the universe. And of course, this enormous amount of data that is coming right now and 1 year ago and in 1 year and in 2 years, all this huge amount of different data, it's really impressive, and we have to use it, right? When you think that Gaia is observing 10% of stars in the Milky Way, or DESI in 1 day with good weather observed galaxies that were split into 130,000 redshift bins or something like that, right? And in 1 month, they observed more than previous enormous BOSS survey in 8 years, right? So this is super impressive, and there is still Euclid to come, and SKA and CTA, and so many, and James Webb, of course, and each of them opens new horizons and gives you completely new opportunities and this enormously big data. And there is this whole radio astronomy, which apart from SKA, which is also extremely powerful. Yeah, so I'm trying to use both sides to figure out how the standard model has to be extended in the end, and to see whether this extension will be simple, like adding a couple of particles and that's it. It's possible, and then at least we know that everything works, or we need something radical. We need another scientific revolution, like extra dimensions, or I don't know what, something like we had to do at the beginning of 20th century.
So what do you hope to see accomplished scientifically over the next 50 years, if you speculate and hope?
Yeah, well, I talked before only on my particle physics side. So on the particle physics side, I hope to discover actually particles which will tell us how to complete standard model. And I want to know whether we can do it by simple extension, or we will have to change something much more fundamental in our picture of the world. But on my, if you want, astronomical side, I'm sure that in the next 10-15 years, we should be able to say whether dark matter is cold or not. We should be able to say whether very small clumps of dark matter exist in nature, because they might not exist because of many reasons. Dark matter can be fuzzy, meaning that it's very light and have very large quantum wavelengths, which prevents very small structure from forming. It can be warm, having primordial velocities that through free streaming would also suppress creation of these very small structures. And there could be some types of self-interactions that do that. So we have to understand whether dark matter is self-similar, its distribution, its clustering is self-similar on all scales or not. And I think this will be a huge fundamental input for particle physics, for extension of the standard model. And this can be done. This can be done in the next decade using gravitational lensing, stellar streams, Lyman alpha forest, and better combining these approaches. So yeah, so this is one of the things. Then I very much hope that primordial magnetic fields or seed magnetic fields can be discovered, because something should have triggered the creation of these relatively strong magnetic fields in clusters in galaxies. So this is another super important direction, and which also can tell us about how standard model should be extended. Yeah, also we know that there are relic neutrinos, which are predicted as robustly as relic photons, and they are as numerous as relic photons, and they should surround us, but we never saw them. So it's not an easy task, but it's a challenge for humanity, right? We know that those guys are there. They keep precious information like cosmic microwave background. So we must find a way to capture them, in my opinion. Yeah.
Thanks.
At least those things. Yeah. Mm-hmm.
So about life as a scientist, what do you like and dislike about being a professor, about being a scientist?
Well, many professors do not like to teach secretly. I didn't like to teach, but now I do. I enjoy teaching so much because I learn how to do it, and I teach myself first of all. So this I definitely like. Another thing I like, which is related, that even apart from teaching students, I learn every week. My scientific work implies that together with my younger collaborators, PhD students, sometimes master students or postdocs, we come to new topics which we need for our main scientific program. We encounter something that we never used, never studied, and we start from scratch, and we are all equal like students, and we learn, and it's super cool being always a student or always learning. It's one of the coolest things in scientific work, in my opinion. Also, it's very good if you feel that you are trying to contribute to our technology or our picture of the universe. So you try to contribute to civilization. What I don't like is that sometimes there is a long way between what you do and well, any kind of application. Because it's always good when you did something and you see how it works, how it is useful immediately for someone. But you can do side projects where this distance is smaller, and I do that always, different ways. So yeah, it's fine. Yeah.
Cool.
Recently, we had a PhD defense, and the student said that in the Netherlands, they have to make some statements for your PhD defense. And one of your statements was, professors should stop encouraging students to have a romantic view of academic career. And I was very much disagreeing. I have very romantic view of academic career. I still think it's great, and I enjoy it a lot.
Excellent. Okay, so now changing topic from science to perhaps the scientific community or your work, maybe even more broadly. So when we speak, it's November in 2022, and the Russian invasion of eastern Ukraine, large parts of eastern Ukraine, has been going on for more than 9 months. And you, as a Ukrainian, have been involved and initiated various initiatives among colleagues and done work in support of Ukraine and Ukrainians affected by the war. Can you tell me about this work?
Yeah, when people are dying, any people, civilians, military, there is no difference now in Ukraine because no one wanted to fight, right? Military people, they didn't attack anyone. Many of them are not professional. Most of them actually are not professional military people. They just normal people who went to war and learn how to do it. And even professional military, they all wanted to live normal life. They are all equal. They never wanted any war. And when these people are dying and suffering, many things become irrelevant to you because you feel it, and you want to spend your time somehow to be useful, to increase chances that people survive, more people survive, and less people get killed or injured. And then I don't know. I had a feeling during this war that I have to use. It's not a time for vacations, holidays, weekends. It's even often not a good time for normal academic research. Of course, you do some things that you have to do because other people depend on you, but otherwise, I still, from the first day till now, I feel that I have to spend as much time as possible trying to use my very limited forces to decrease chances that someone is killed or injured. And this can be done in many different ways. You can organize, you can use your social or professional network to organize people to find things that are needed, to buy them, to deliver them, to make this logistics chains, to connect those who need urgent help with those who can provide it. You can do, if you are a scientist, and you can do some research or write some codes or whatever. You can do also more, maybe sometimes more sophisticated things to help people. Yeah, one thing I did is so I tried to find an excuse for me that I'm here in safety and other people are fighting. So I wanted to use every minute such that it's helpful to someone. That was my feeling. Yeah. So yeah, we did many different things, supplying people and helping in, as I said, in many different ways, including scientific, helping people to survive. But one thing I want to mention explicitly, because maybe someone will like it and join, is that we found physics teachers from Kherson and Kharkiv and other cities which were severely suffering from the war. We found there are these amazing teachers in Ukraine who prepare every year consistently super motivated, great students that win international Olympiads in physics, go to best universities and make brilliant, successful study and careers there. And this happens for decades, and the same teacher is preparing such students every year consistently. So these are really amazing, unique people. And there are such teachers everywhere in Ukraine, but first of all, we paid attention to those who are in these areas in the south or east of Ukraine. And we found them. They were all, of course, displaced as refugees inside Ukraine or outside. And then their children, their students, high school pupils, they were all also displaced. And we connected them back, and we organized an online course of physics. That's because many children, their education was damaged because, of course, during the war, it was very difficult to learn. And from 1st of July, we started this course that goes for 4 years, 4 school years, for age levels. And in each year, there are groups of different level, different intensity of the program. And this is real full-scale course. So they have many lessons per week. And it goes from 1st of July till now. It's supposed to take the whole year. During summer, it was easier because children were had more time available, and they wanted to compensate what they lost during the war. And now they do it as additional course after because they're all everywhere, not in their normal usual schools, but somewhere. And the level of physics teaching is not always equal, and they wanted to keep up with what they used to. And also other children just wanted to join because they found this and it looked good. So we have and teachers, they feel like they're very much demanded. They do their work, what they can do, their job, and there were about 500 students registered when I checked last time, and also almost 10 teachers, and teachers get salary, and all this goes online. So this is one of the quite successful, I would say, projects that I'm very happy that it happened. Yeah, so I emphasize this one and not many others that we were involved with my colleagues and students and postdocs, because this one is, at least I hope, should be appealing for any physicist. So if you want to somehow support it or whatever, you are very welcome.
Excellent. Thanks for sharing. So switching to EuCAPT. So EuCAPT was formed to stimulate interactions between astroparticle physicists within Europe and cosmologists. So what role do you think EuCAPT can play for the community?
Yeah, I mean, community is very important in science and physics, because people have to exchange ideas, right? Typically, if you have a good university with a strong group which has regular meetings, seminars, journal clubs, right, it forms some level, right? Because anyone can make mistake, anyone can say bullshit, right? The power of science is that if you have a group of colleagues that are motivated, active, and interested, every bullshit you say will be immediately noticed by someone. And then after some time, you run out of bullshits you might say about certain subjects, right? You already tried to do it, or someone else did it, and you already know that it's bullshit, right? So even in this way, it's super useful. So having a community that works on the same subject, facilitating exchanges of ideas, meetings, talks, all these normal forms of scientific life, which are not easy to organize, which are not easy to support, because we all tend to have our own local business. I'm teaching today, I have a visitor, I have my grandmother, I have vacations. So it's not easy to support the community. And if there is a framework which helps people to exchange ideas and talk to each other and develop some priorities, strategy. I mean, I'm, of course, want to be very careful. I don't want this to be somehow too formal and bureaucratic, but if it's done in good scientific way, when people discuss and exchange their opinions, what is more urgent, what is more important, I mean, I think it's very good. And I think field of astroparticle physics is diverse enough and large enough, and on the other hand, it's well defined, that all this is very, very, very much required. This framework that allows to keep the community as a community with all these nice features of exchanging ideas. Yeah.
Cool. So you mentioned that now is a very intense period, but usually how do you like to relax outside work? Do you have any hobbies that you'd like to share with us?
Yeah, I mean, I have maybe three kinds of hobbies. One is change of work is the best work. So I have, apart from changing work, different kinds of projects inside science, which I also enjoy. I also have a project that is related to information management. So we did Profi Science. It's a system that has one of the biggest collections of open source documents in science, in all kinds of sciences. And then we analyze it in our own way, combining semantic approach and deep learning. So knowledge organization in form of ontology and statistical approaches behind deep learning. And as a result, we have many ways to find really papers that are very similar to a given one, not superficially, but for an expert, like an expert, you write your own paper and then you find similar, and you find whom you have to cite because you could have missed it, or you find an interesting paper and you really find 10 more interesting that you would not find that easily. Well, sometimes one, sometimes 5, but yeah, any of them is very useful. Or you can match profiles of people, so you find experts for, yeah. So all this, I mean, it's a project, very serious. There are people who work on it full time, but for me, it's a change of work, which I perceive like one kind of rest or relaxation. Then, of course, I want to read. I read less and less, but I listen audiobooks more and more, because I can do that when I travel, when I do something, I cook or whatever. And I think I get used to it, so I keep reading level without having time to read, actually, using audiobooks. And then I like sport. I like hiking. I like swimming in free water, not in the swimming pool. I like biking. I like skiing. So I try to do it every day, more or less. Otherwise, I won't survive. I travel 22 kilometers by bike from home to work when I'm in the Netherlands, one way. And I tried when I'm in Switzerland, I try to go to hiking or skiing every weekend. I get in when I come to Switzerland. I swim in Geneva Lake almost the whole year. I probably will swim tomorrow. Yeah. So that's that's one of the best way to relax for me.
Right. So a final question. So what advice would you give to a younger colleague or maybe a student or beginning postdoc who are only just now starting out in the field?
Yeah, it's easy. First, I would say, if you ask yourself if you can live without science, if you are here for a career or for whatever, don't do that. There are much easier and faster ways to earn money or do career in any other senses, right? And don't do that. Do it only if you cannot live without it, if this is your real passion, you enjoy it so much, and you keep romantic perception of academic career, honestly. And yeah, and then if this first condition is satisfied, I can repeat the words. That here Toft told me on my first postdoc. He said, I appreciate this words a lot. He said, don't pay attention to fashion or whatever people think. Do only what you feel right at every moment. And one day you will do something very good, not because you are super smart or independently on how smart you are, but because you will be lucky. No, this is what he told me, and I think it's a very good advice, so I can pass it to anyone.
All right, thank you. So now we reached the end of this interview, and I would like to thank you very much, Alexey, for taking the time and answering the questions, and it's been very nice. Thank you.
Yes, thanks a lot. It was relaxing.
All right, so and with that, we close this video profile.
Yes.
More profiles will be published in the future on the EuCAPT webpage, eucapt.org, so please check that out. Thanks for watching, and goodbye.
Yeah.